Good evening. My name is Michelle Tyndall, and I'm going to be your facilitator for tonight. Welcome to our Snapshot series, our 2024 Snapshot series, where we're going to take a look at a lot of topics related to three-dimensional teaching and learning. And tonight's topic is going to be making thinking visible. A little bit about myself. I taught high school for 26 years, chemistry and physics and other topics as assigned. And then I spent about 5 years as a curriculum coordinator, K-12 math and science, and now I'm a facilitator for Activate Learning. So it's my pleasure to be here tonight with you and to share some things from my classroom and from classrooms around the country that I have worked with. So welcome. You'll see in the chat that I have put in a link to our agenda page. So I'll show you that real quick here. And you'll see that on our agenda page, we have all the links that you're going to need for tonight, and then some additional resources. So you'll see that there's links to the articles that we are going to be taking a look at and some of the lesson slides that we're going to be interacting with tonight. So it's not going to be just listening to me talk for an hour. We'll actually have some chance to engage in some of these pieces. So you'll notice there's a fair number of things here, and I'll add some additional resources after tonight. So go ahead and bookmark that page and refer back to it when you get a chance. So we're going to go ahead and get started with our presentation for tonight. So if you could go ahead and introduce yourself in the chat. If you could add your name and where you're from, and then what's your role in the educational setting, and then if you teach, what grade level or levels do you teach, and or what subjects do you teach? So go ahead and add it into the chat. Welcome, Science Museum educator. What a great connection to what we're going to be doing. High school chemistry and biology. Welcome. Instructional coach. Nice. We have a great variety of folks joining us tonight. I see that. All fields, yes. Awesome. Well, welcome to everyone. And as I mentioned, we're going to be getting into a number of things. We have another person, a special education teacher in therapeutic day school setting. Thanks for joining us. It's really nice to have a wide variety of folks and attending to special education and coaching and just all the different settings and the alternative education setting in the museums. Like it's just nice to have such a wide variety of folks with us today. So welcome, and I hope you leave today with something that you can use in whatever space you're in tomorrow. So thank you for joining us tonight. For those of you who just joined in, I'm going to put a link to our agenda page in the chat. So go ahead and open up that link. And then also, if you could, go ahead and put into the chat your name and where you're from and what your role is. And then if you teach, what grade levels or subjects do you teach? So with that, we're going to go ahead and cruise on to our first assignment of the night. So go ahead and in your space, wherever you are, sorry, let me get to a quick chat. We're going to talk a little bit about a loan zone today. So a loan zone, if you think of it in your classroom, or in your educational space would be that time when you're collecting your thoughts and you're just jotting down your thinking. So, in your alone zone, in what ways do your students make their thinking visible? And in what
And in
ways
what way?
do you and your students make use of representations for sense making? So, how do you have students make representations to kind of make sense out of what they're experiencing in science? And I'm going to give you a minute to jot down your thoughts in on your own device or at your space, and then we'll share those in a moment. So go ahead and think of what your thoughts are on those two bullets, and I'll give you about a minute.
Ever. Tiffany, that buff.
Okay, about 10 seconds left. Perfect. Okay, so we're going to do something that I would do with my students and that I do with groups of teachers that I work with as well. So we're going to use an application called Slido. And you'll see that there's two ways we can interact with it. So I'm going to put the link into our chat. And then I'm also, you'll see that there's a QR code there for you. So if you have your phone, you can take a picture of the QR code and it will open up the app. Or you can click on the link in the chat and it will open up a Slido window. And in that window, you will be able to add in some 1 and 2 word answers to our question: in what ways do your students make their thinking visible? So go ahead and add in as many of your ideas into that um, app as you can. Maybe 2, 3, 4 different ideas of 1 or 2 word answers. Like, how do you have students make their thinking visible? Okay, and you'll notice as we are adding in more typing, more words, you'll see that our word cloud is developing with all these different words. And you'll see models is huge right there in the center, telling us that we've got quite a few folks that are adding models in. I'll give you about 20 more seconds on that. And gestures, nice. Great. So let's take a minute just to look at what we see here. We see models, we see drawings, there's science notebooks, claim evidence and reasonings, highlighting and graphs, gallery walks to share their thinking, um, lots of drawing models, drawings, some writing. We have talking with their group, asking questions. So there's so many ways that we can have our students make their thinking visible. And in this case, we are going to take all of these ideas and we're going to narrow down to a few tonight. A few pretty powerful ones that are used in OpenSciEd. They're used in a lot of different modeling instruction, a bunch of different curriculum, and you'll see them in a lot of the um, articles and publications and journals and things. So we're going to take a look at some models tonight. We're going to take a look at particle models. We're going to take a look at how do we take a look at graphs. And then how do we use all of those pieces that then take a look at claim evidence reasoning and writing, and then bring it into our previous month's topic, which was productive discussions. So we'll keep on moving along with our presentation today. Thanks for taking part in that activity there. Let's go ahead and cruise back to our presentation here. There we go. Okay, so into the chat. In what ways do you and your students use representations to help students make sense of science? So we've got ways that they make their thinking visible. Now we're thinking representations. So how do they represent their thinking? How do you make use of those representations in science? So into the chat, go ahead and type a couple ideas, but don't hit enter just quite yet. In what ways do you and your students use representations to help students make sense of science? Okay, go ahead and hit enter. And then go ahead and scroll up. We have things like visualize the invisible and to compare quantities, flowcharts and graphic organizers, describing how phenomena works in a model. Great. So lots of good ideas of using representations to help students make sense of science. Legos and models, pictures and discussions. So we have a lot of different ways that we can help students make sense of the science. And it goes beyond just getting the right answer on our teacher questions, right? So if we think of what students are used to doing in their little schema of school, they do something with an activity, then they answer questions about the activity. They're looking for that right answer, and then they get evaluated on that activity. So when we flip and we're looking at three-dimensional instruction, it looks a little different for students in that they're trying to make sense out of the science. So I love all the ideas that you've shared in the chat about how students are trying to make sense out of the science. So taking a look at what we're going to be talking about tonight, we're going to do a little bit of introduction to making thinking visible. Then we're going to pop into some OpenSciEd lessons, 2 different lessons for drawing and writing for sense making, and then share some ideas to go ahead and get started. So let's take a peek at making thinking visible. So we have, in our previous webinars, we talked about three-dimensional learning, and some of you mentioned that actually in the chat about three-dimensional learning, and then you also mentioned some pieces in our word cloud. So with the NGSS, we have our disciplinary core ideas. That's what students are learning. They're used to that content that they need to figure out, learn, and be able to use on an assessment. The other two pieces, the other two dimensions that are being added in with the NGSS are the science and engineering practices and the cross-cutting concepts. So when we think of those two, we've been doing labs and activities in science for a very, very long time. But the cadence of a unit would be that students learn a whole bunch of things, and then they do an investigation, and then they use what they've learned to answer questions about that investigation, to explain what happened. The NGSS and the framework for K-12 science flips that up and has students engaging in the science and engineering practices, to figure out and investigate a phenomena and to put their thinking together and figure out the key science concepts. So what you'll see is that the science and engineering practice and those cross-cutting concepts, that lens that you look through phenomena like the matter and energy and systems and cause and effect, like all of those are ones that are now being elevated up to equal standing with the disciplinary core ideas. We know that we can't learn the disciplinary core ideas without really doing science, and we can't do science without those core ideas. So it's really intertwined together. So you'll see as we go through today, we're putting students in that role of figuring out and using those all three dimensions in order to figure out the science. I've shown this in all of my webinars, and I like this graphic because it tells so much about what we're doing in science and how it relates to mathematics and ELA. So our topic tonight really is going to look at this models with mathematics, developing using models, using mathematics and computational thinking, but then also into this green section where we're obtaining and evaluating and communicating information. And then we're also going to look in this blue section where we're constructing explanations and designing solutions, because all of that's what our students are going to be engaged in as they are trying to figure out science and those key ideas. You'll notice that in this middle section, there's some really powerful things as well, engaging in argument from evidence, constructing viable arguments and critiquing the reasoning of others. So all of these pieces are pieces that our topic tonight really leans into. The shift, students learning stuff to students doing science. You'll see on the right, students are out there, they're in the museums, they're in doing activities outdoors, and they're doing those activities and having those common experiences to try and figure out what's happening in science. So we talked about early on in our webinar series, how do you make that shift to three-dimensional teaching and learning? The idea is begin with some anchoring phenomena. What draws your students in so that it's relevant? Ground that new learning in evidence from doing science. So put those investigations up front and then put the students at the center of their learning, which is what we're talking about tonight, and helping them to then grapple with those new ideas, to communicate their understanding, build on each other's ideas. And then the teacher in this space is going to facilitate those discussions and they're going to guide the students in their learning, but doing so with the students making their thinking visible. And that's an important piece, is that during this figuring out, you want all of your students to have a chance to share their understanding so far. And that's where we see this shifts in writing and drawing for sense making. So this comes from OpenSciEd. And I'll give you a second to take a look at what the less focus is on and what the more focus is on. And I'll also put a link to that in our chat so you can pull that up on your end as well. I'll give you a minute to kind of take a look at that. So we're going to lean into taking a look at what's on this right-hand side, right? Writing and drawing for students to figure things out. They're building an understanding, and they're building an understanding of the phenomena and the science ideas. They're not getting these ideas up front in a lecture and notes. They're getting a common experience and investigation, and then they're trying to make sense out of that. The second part down, writing and drawing to make sense out of those investigations and readings and experiences, to try and put together their learning and communicate it to others. And then when we take a look at what we do as teachers, right, we want to give students lots of different ways to demonstrate their understanding. So the prioritizing multiple different forms of writing and drawing across the unit gives all of our students an opportunity to engage in the understanding and the sense making. And so with that, I'm going to show you a video. It's a short little video, but I think it kind of hits home why we're doing what we're doing for making students thinking visible. So let me bring that up for you. This is a short video. It's about 2 minutes long. And there's two different teachers sharing their experiences with making thinking visible. Give me a thumbs up if you can hear it when the audio comes back on.
The modeling, letting them
Perfect.
make sense. We did this a few times as I was learning more about sense making, but letting them draw or letting them write for sense making. Okay, so they've read this article or we've looked at data, and then however they wanted to present it. You know, in the past, I had a expectation on how I wanted them to write or how I wanted them to draw. And then when I understood the concept of sense making, it's what makes sense to them. And so allowing them the time and the opportunity to draw or write in a way that made sense to them, and then me just looking at it as, oh, let me understand what they know, instead of me coming with a preconceived idea of this is what I expect, and if they don't say it or draw it the way I expect, it's wrong. You know, that was what I did traditionally. But with the new training from OpenSciEd, it's however they want to express it. You know, then I look for the level of understanding instead of looking for my expected way of them doing it.
Is built in that the modeling evens the playing field. I'm going to say that the being able to represent their information in different modalities, it equals it all out for everybody. Instead, and I say this and I'm kind of like I'm tearing up, but it really helps those students that are really having difficulty. I think of this young lady, and she's like, I've struggled every single year in science and I just don't get it. And she said, this year I'm successful. I'm making A's. I'm able to understand that I can represent my information in multiple ways. And whenever we're looking at those pieces of evidence in our mastery, I'm like, I want you to focus on this one because this one has this modality versus this type of representation versus this representation. And so I look at the different types of representation that they can show for meeting that goal, and the understanding of that standard. And then I gear it towards what are the students' needs individually. And OpenSciEd does that beautifully. It really does think about the different types of learners that we have in our classroom.
Okay, so taking a look at that and what they had to say, just jot a couple of your little takeaways into the chat. What kind of spoke to you or what resonated to you from that video? So what resonated with you from that video? Student choice? Definitely not everybody can represent their thinking the same way. Meeting students where they're at. It equals the fields for students to express what they know. Yes, Lindsay, your students with emotional behavior and learning disabilities will have much more success with this. Yes. Equals the playing field for our multilingual language learners. Yes. So, taking a look at this in terms of just leveling that playing field and giving all students a chance to show their thinking is super important. But from the teacher side, it offers a huge benefit as well. You get a chance to see and hear and talk to students about their thinking in ways that you wouldn't before. So taking a look at what we're going to do next, there's actually an article, and then there's 3 sub-articles related to that. And I'm going to put the link into the chat, and then also you'll see it on our agenda page. I'll show you on our agenda page where we're at. So on our agenda page, we are right here under the readings. So the Making Student Thinking Visible is the reading that we're going to do right now, along with the one that comes after it. Right at the bottom, you'll notice that there's the second reading, Making Students Thinking Visible Through Discussion. Last month, we talked about productive discussions. And the precursor in many cases to our productive discussions is having students make their thinking visible. Drawing models, drawing representations, somehow making sense out of data, sharing it with a small group, and then sharing it with a large group. So while we think the drawings and the writings and the diagrams are important, they're also oftentimes very connected to our discussions. So I'm going to give you about 3 minutes to take a look at these 2 articles. So on the first article, you'll see that there is an introduction here, Making Student Thinking Visible. And then it kind of sets the stage. And when you scroll down after the bio of the author, you'll see the second article, Making Students Thinking Visible Through Discussion. And when you open that one up, you will see this article right here. And this goes in and actually shows you some additional examples and talks about a discussion here. And talks about the different types of discussions. So if you could take, like I mentioned, about 3 minutes to kind of peruse these 2 articles, and then we'll come back. And in the chat, I'm going to ask you, what were your notable ahas, or what were your takeaways from these readings? So think of what you're going to share in the chat about your ahas or your takeaways from these 2 readings. So again, on our agenda page, you'll see the Making Student Thinking Visible, and then Making Students Thinking Visible Through Discussion. So those first 2 bullets under the readings. Okay, go ahead. I'm going to give you about 3 minutes, and then we will come back together in about my time, Eastern time, 7:33. So in about 3 minutes, we'll come back together. And we're going to come back together. So we had two different articles. So the first one, just teeing up a little bit about why it's important to make thinking visible. And the second one about making thinking visible through discussions. So if you could put two ahas or takeaways into the chat and just pause, and let's not hit enter just yet. But I'd like to get your thinking about what kind of resonated with you from these two readings. Go ahead and hit enter. And then scroll up and take a look at what everyone had to say. Things like students evaluated themselves, sitting as this at the same level as students. So in the article, it talks about the teacher being in the same level as the students, right? Taking part in the discussion, being part of the circle. Circle up agreements. Last month in our webinar, we talked about building a community of learners. And we had these community agreements that were important for our discussions and for having that community of learners. Allowing students to explore science provides them with opportunities to teach and learn from peers authentically. Isn't that what we do in our everyday lives? Give them time beforehand to think and write about shared experience with a phenomena investigation, and it allows them to build on each other's ideas. So as we're making the shift to more student-centered learning and students figuring out instead of just learning about science, we have to give them that space to grapple with their thoughts, to learn from each other. And then the teacher takes on that role of that facilitator of the learning. You know where your students need to be. You know the common experiences that you've given them. And then they're going to use all of that knowledge and the experiences to kind of start to make sense out of things. So I am on our screen right now. You'll see that when you take a look at what the article is talking about, like NGS design lessons will look less like the teacher at the center. Student artifacts showing only answers, and teacher guides focuses on what to tell students. To more, the classroom discourse is the focus, and students' voice is being lifted into the room. The student artifacts are many and rich, right? And it shows their reasoning behind their answers. It lets them have lots of opportunities to show their thinking over time. And then the lesson provides support to teachers for eliciting the student ideas. So great. So then when we are taking a look at the discussions, when we look at a couple of the articles here, sense-making discussions and scaffolding for the discussions. So when we think about how we want to have students talking, oftentimes it's the teacher that's doing these questions that lead students to uncovering their ideas and sharing their ideas. So in our agenda page, you'll see that there's the 10 goals for productive discussions and 9 talk moves. So in that, it gives teachers some ideas of those sentence or question starters that will be very helpful for them as they are running these discussions. And then the circle up was something that was mentioned in our chat. What do these agreements look like? What do we want our classroom discussions to look like? So thank you for taking part in that reading. As we are continuing with our thinking here, going to hop back into that same article. We're going to have 2 more articles. I'm going to give you about 3 more minutes again to take a look at the next 2 articles that were linked off of that intro article. They're on our agenda page as well. The first one is the going public, revealing student thinking in science. And what does it really take to get high school students to make their ideas visible? Because as we know, our high schoolers have a lot of reasons why they may not want to share their thinking. But when they do, the class is so much richer. So I put those two links into the chat. Again, they're also on our agenda page. So take about 3 minutes to read through those as well. And then we'll have another quick discussion in our chat and a little bit of sharing. And then we'll pop into a sample lesson from OpenSciEd and see what they do with modeling and with making thinking visible. So again, we're going to take a look at these two articles, the going public and what does it really take to get high school students to make their ideas. We'll come back together at 42 after the hour.
And eventually we'll be getting into breathing too. Wow.
Great. Welcome back, everyone. So we took a look at two different articles. One of them in terms of going public. That was one that where we were talking about students going public in their classrooms, developing claim evidence reasoning. And then the second one was focused in on our high schools. So what did you notice in the articles? What type of representations did you see in the articles? How were these tasks making thinking visible? So what did you notice in the articles in terms of what students were doing? Go ahead and add it into the chat. Go ahead and hit enter when you're done. Yes, finding how comfortable your students are and meeting them where they are. Students were not intimidated. What else did you notice about some of the teacher instructional moves in those two articles? What did you notice the teachers doing? Go ahead and hit enter. Teacher was not the leader, very much so, right? Teachers become listeners, right? So when the teacher becomes the listener, the teacher can actually make a lot of instructional moves in real time and not be waiting for later on to look at assessments in order to make the instructional moves and changes during the class period. Facilitator routines and revising models. In both articles, they talked about the teachers having students working in groups, right? So leverage the power of students working in pairs, working in small groups, having opportunities to do lots of thinking together and building their understanding together, right? As teachers are facilitators, assessments change and are not always graded. So as we're having students making their thinking visible, they're explaining their thinking so far. That doesn't necessarily mean we're grading their thinking so far, right? We're giving them feedback on their effort. We're giving them feedback on what they put together so far. But we know that that actual assessment of what they've learned might come later on. Also, when the students are putting all of these things on their whiteboards, they can then have this routine of where they're going public and they're sharing it with the whole class. So think of a scientist circle, and we're going to talk a little bit about that with our OpenSciEd lesson before we end tonight. Students are going to share their work in a gallery walk or in the scientist circle, talk about it. And teachers are going to facilitate that discussion. What are the similarities and differences? And then come to a consensus model. That's where the teacher has the opportunity to take the student understanding so far and attach it to the science and attach it to the vocabulary and the scientific principles that you're learning in the classroom. So thank you for your reading and your responses on that activity there. So taking a look at what we're going to kind of investigate here today is drawing and writing for sense making. We're going to take a look at some OpenSciEd sample student activities where students are doing some models, initial and consensus models. How are they doing things like particle diagrams and using charts and graphs? And then how do we use this idea of claim evidence and reasoning as another way to have students show their thinking? So this is coming from a lesson in chemistry. This is from OpenSciEd Unit C1, which is taking a look at the phenomenon of sea level rise. So students will watch three videos about the impact of sea level rise on these three different communities. After they watch the videos, I should say, they're going to then take a look at some additional data of what's happening in the areas. So they're going to do a notice and wonder chart. So from the very start in OpenSciEd, students are recording what they notice and what they wonder on an individual basis. This is another artifact of their thinking. This lets you know what they're coming to the table with, what they're noticing from the readings, and the videos in this case, and then what are they wondering about? Okay, so it's another place in their science notebooks, and folks mentioned in our word cloud science notebooks. This is another place where it's kind of archiving their thinking and their noticings and their wonderings. Then we're going to take a look and have them do some turn and talk. So we talked about discussions as part of our classroom activities. They then take a look at different ways that we measure sea level rise. And there's two different ways. We look at tidal gauges and we look at satellites since 1982. Then students have an opportunity to take a look at some graphical data. And then we use a prediction tool to take a look at what those sea levels might be in 20 years. So into the chat, jot down, what do you notice in this graph in terms of sea level rise from 1900 up through 2020? What do you notice? What do you think will happen in 20 years? And how do you think it'll affect people? Pick one of those questions and go ahead and answer it in the chat. Go ahead and hit enter when you get a chance. What do you notice about the data? What do you think is going to happen in the next 20 years? Some good questions here. It's trending upward, but what happened in the 1910s? People were forced to move as the sea level keeps rising. Sea level will continue to rise, and islanders will need to move. Nice. Sea level rise has been increasing since the 1900s. So students are engaging with this phenomena and trying to make some sense out of it. Then later on in the lesson, we take a look at different things that could be causing water levels to rise, right? So where might we be seeing these types of features on Earth, and what might we be noticing in terms of water levels rising in these different locations? And we have a glacier, we have the Mississippi River, we have Yellowstone Lake, and we have sea ice in the Arctic Ocean. And then our students are asked to develop models of what they think is causing sea level to rise all around the world and what's happening at the particle level to cause sea level to rise. So let's think about that for a second. So what do we think is causing sea level to rise all around the world? And then what's happening at the particle level to cause the sea level to rise? So I'd like you to take a couple minutes, not long, and just think about or sketch out what you think is causing sea level to rise all around the world and what's happening at the particle level to cause that. Okay, so from here, our students would make their original models, their initial models, and then they would share their initial models with a group, and they would notice the similarities and the differences. So one of the articles talked about giving students a chance to write down their own thinking from the start and then go ahead and share it. So in this case, students would do their model on their paper and then they would share it with a group. And then they would, after that, take it as a class and they would design a initial model. And I see in the chat a couple questions. So how would you share models digitally? And then what do these models look like in the drawings, right? So how would you share them digitally? So on our agenda page, you'll see that there is a link to a Google slide deck. And one of the ways in which I would share them digitally would be to put a slide deck together and have a template, right? So later on, we won't get to this lesson tonight, but students are making some particle models to show density differences in water, for example. So using the tools, they could actually draw their models, and using particles and arrows, they could do that actually digitally on this shared Google slide deck. Each group or number of students could have their own slide. Additionally, if you have a shared Google slide deck and students write it in their notebooks, if they have a camera on their computer, they can actually take a picture with their computer and put that picture right into their slide deck as well from their drawing. So you can do a lot of different ways. I also see in the chat, Sage Modeler might work, and then also AutoDraw. So lots of tools are out there for you to make use of. I think a lot of students are comfortable in the Google suite of tools and using the tools here. So just to give you a little bit of a background of how I created this particular slide, I took the little shapes and I just did a copy paste 20 times, and then I just aligned them all up together. So this is actually a stack of about 20 little red circles. Then I did the same with the blue and the black, and then the arrows. So all my students needed to do is literally draw them, so the digital space doesn't get in the way of their thinking and showing their modeling. If they wanted to do additional icons or things like that, they could do it on their own. But then once I created this one slide, I duplicated it 7 more times or 6 more times so that each group in my class could have their own slide and draw their modeling. And then everybody in the class could also see their other groups' models and compare and come up with similarities and differences. In the classroom where you have whiteboards, this could be done very easily on a whiteboard as well. And then go ahead and they could compare whiteboards either by putting the whiteboards like on the floor and have a gallery walk, or holding them up in a scientist circle. And then one of the other questions was how would what would the models look like? So when the students draw their model of the sea level rise, I would then bring them together. Like one of the parts of this lesson is to bring them together to come to an initial consensus model. So I would have them come together and have them share with me what kinds of things were in their model. So oftentimes students will say there's some sort of glacier in their model, right? Some students would say also that there was a river in their model. So they would say, we're going to have some land, and then, here's our land. And then we're also going to have a river that kind of goes through our land into the ocean. And then we're also going to have some rain. So students would say we're going to have some rain clouds, and then we're going to, my rain clouds went away, rain clouds. And we would build the model together, but through the student voice. The students would be sharing what they had had in their models, and then we would come up with our model for our sea level rise from all the different things that the students had to say. So it's through those drawings, individually and then as a group, and then going to our class model, that we can then try to build a class understanding. Great. So we have a few minutes left, but I also want to share a little bit about your next steps and things that you would see in OpenSciEd. So students later on in the unit would be looking at temperature changes. And that's where we would have students do some drawing to kind of figure out what makes one liquid float and another liquid sink. So they actually would then come up with particle drawings of what they think would happen with their fresh water and with their salt water. to try and model what's happening with our sea level rise and with icebergs melting and the rate of that melting. So again, we would have students do some modeling here of their initial thinking. Then they would do some additional investigations. And once they do some investigations, then they would come back and figure out what sorts of data they need to collect, do the investigation. So here they would actually do some investigations and then come back and have a consensus discussion and then revise their models. So they would be coming up with, what is your new model going to say after you do this investigation? So that's a powerful piece. The initial models and the models that your students are drawing might not be perfect at the start. That's okay. You're having them show their thinking. And then they do some more work in the science using the practices, using the cross-cutting concepts. Then they come back and they revise their model. And it's through the sharing and the consensus models that you're able to then tease out their thinking, bring the whole group together, and then come up with their final models of what they can agree upon and attach the science and the vocabulary to it. So a quick question in the chat, do you have them do new revised models or put the changes on their initial models? That's a great question. It depends on where they're at. Sometimes I'll have students take a new color, and if their old model just needs some tweaking, put the tweaks with the new color. If there's some big overhauls of their model or they want to change it up significantly, I have them draw a line of learning and then draw their new model underneath it. And if students want to just grab our consensus model and bring it into their notebook, that's okay too, because that's part of their learning. So they're going to compare their initial model with our class consensus model, and they'll be doing a lot of learning of what was different and what was the same as theirs and what they needed to change and do differently. So with that, I'm going to skip to our last slides of the next steps. Give students individual think time and write down their thoughts. Have them have lots of opportunity to share their thinking with a partner or small group before their whole class. Ask students to draw models to explain their observations and data. And then allow your students multiple ways of showing their understanding with graphs and diagrams and written claims and models. And with that, we're at our 8 o'clock time. So I thank you so much for joining me this evening. And I will put this slide deck into the agenda page. So go ahead and bookmark that and you'll see a PDF in there. And you're welcome to hang if you have any other questions for me. But other than that, we are done with our formal part of today.